Hello students, in this video we find the solution of homogeneous partial differential equations. So given dou square z by dou y square is equal to z. So this we can write it as dou square z by dou y square minus z is equal to 0. So when the partial differential equation is homogeneous, it is as good as ordinary differential equation. So we can rewrite this as d square minus 1 of z is equal to 0, where the z is dou by dou y. Find the solution of this homogeneous differential equation. So the auxiliary equation is replacing d by m, it is m square minus 1 equal to 0. M is plus or minus 1. So the complementary solution here, in case of homogeneous differential equation, the complementary function itself is the general solution. So therefore, the solution for z is, in case of ordinary differential equation, we write the solution as c1ay1 plus c2 a1 y1 c2 a2 y. Now here, since it is the partial differential equation, instead of writing an arbitrary constant, if the partial differential equation is with respect to y, then we need to take an arbitrary functions of x. So the solution of this given problem is f of x e raised to, the root of the equation is 1, so it is e raised to y plus g of y is equal to, g of x is equal to g of x into e raised to minus y. So this is the solution, a general solution. To find the particular solution, we have to put the conditions given in the problem. It is given that z is equal to e raised to x when y is equal to 0. So if y is 0 and z is equal to e raised to x, substituting in the solution of the equation, so let me take that as 1 e raised to x e raised to 0 f of x e raised to 0 plus g of x e raised to 0. So it is f of x plus g of x is equal to e raised to x. So take this as equation number 2. Now the another condition is given that dou z by dou y is e raised to minus x. So to substitute this condition, we need to differentiate z, that is 1, with respect to y partially. So differentiating 1 partially with respect to y. So it is dou z by dou y is equal to f of x is constant. The differentiation of e raised to y is e raised to y. Here g of x is constant. The differentiation of e raised to minus y is e raised to minus y into minus 1. So this is f of x e raised to y minus g of x e raised to minus y, dou z by dou y. Use the second condition, dou z by dou y is e raised to minus x when y is equal to 0. On substituting, it is e raised to minus x, e raised to 0 is 1, so it is f of x minus g of x is e raised to minus x. So take this as equation number 3. So solving the equation 2 and equation 3, so we have f of x plus g of x is equal to e raised to x and f of x minus g of x is equal to e raised to minus x. So the g of x get cancelled. 2 times of f of x is, here it is e raised to x plus e raised to minus x. So that we can write it as f of x is e raised to x plus e raised to minus x divided by 2. So if you see, this is nothing but cos hyperbolic x. So the value of f of x is cos hyperbolic x. Similarly, Similarly, if I substitute f of x in the equation 2 or 3, or if it is 2 minus 3, then it will be f of x plus g of x is equal to e raised to x. F of x minus g of x is equal to e raised to minus x. On changing the signs, we have the f of x get cancelled. 2g of x is equal to e raised to x minus e raised to minus x. So therefore, g of x is e raised to x minus e raised to minus x divided by 2, which is nothing but sine hyperbolic x. So we got the solutions of f of x and g of x. Substitute that in equation number 1 to find the solution of z. So it is z is equal to f of x, which is cos hyperbolic x e raised to y plus sine hyperbolic x e raised to minus 1. Thank you.